introduce the mammal and the human. We've already looked at the frog and the chick. Now really the basic end of this course is the mammal, the human. Remember in Amphioxus and the sea urchin, the way this thing gastrulates is just by pushing in of a ball. And remember, the key to gastrulation is you need to get stuff from the outside to go to the inside of the embryo so that the embryo could become layered and start looking like a real organism. So that's what's happened here. And eventually, in, let's say, Amphioxus, you have a neural tube or neural plate which will form the neural tube, and you have somites. Now we went to the frog. Remember, in the frog, you can't push in that ball because there's too many dense yolky cells. So what happened is that the stuff from the outside creeped in around these yolky cells. So we did, in fact, get stuff going from the outside to the inside. And the yolky cells are basically here. And you get something that looks very similar to Amphioxus. You have the neural plate and the somites. I'm just picking some stages to show the similarities in the final result of these organisms. Then we went to the chick. Remember, the chick, only the little tiny blastodisc cleaved, sitting on top of the yolk. Because the yolk is so dense, you can't even creep into it. So remember that in the chick, cells moved from the outside to the inside a little differently than in the frog, and of course differently than in Amphioxus and the sea urchin. Then we finally get the chick embryo, as we mentioned, and there's a lot of yolk which it will use for nourishment. And we get to the same thing again eventually, the neural plate with the somites. So note what's happening. The means are different, based primarily on the yolk quantity and distribution, but the end is the same. Now we get to the mammal, the human. It gastrulates just like a chick. It has a yolk sac just like the chick, but there's no yolk. That's what evolution did. Evolution resulted in an embryo that basically evolved more or less from the chick, but no longer needed the yolk, and the eggs are tiny and they don't have much yolk, because in the mammal, in the placental mammals, they get their nourishment from the mother. They don't need the yolk. And what we have is the same thing again. Here's a neural plate with somites. So, this is the beauty of embryology. We have different patterns, but they get to the same end. An organism that functions, that's beautiful. Okay, so what about the human? And what about other placental mammals that get their nourishment from the mother? Well, in the case of the human, the egg is ovulated out of the ovary. It goes in the oviduct, and then sperm meets it and fertilizes it. And then we get the beginning of development. And finally, at about 6 days, this embryo implants itself in the wall of the uterus, and you have projections from the embryo, projections from the uterus, and you start getting the formation of the placenta, which is the structure that allows the embryo to get nourishment from the mother and give off its wastes. And now we'll move on to some slides of mammals and a human.